Let's learn your lesson in less than 3 minutes. When we think of derivative, we think of slope.
Oh my God!
Let's take a straight line. This one has a slope of 2. If by going one step to the right, we go up 2 upwards, the slope is said to be 2 to 1, which is 2. If we have a 10% slope, it means that by traveling 100 meters to the right, we climb 10 meters.
Holy! Look at all this damage!
It is also possible to have negative slope.
What? What the f?
If going to the right, we descend. So we can say that the slope of a line is the distance to the right, dividing the distance up. If we have 2 points, it comes down to this formula. Indeed, the height f of x2 minus f of x1 gives us the distance up, and x2 minus x1, the distance to the right.
Explosion.
Take any function and 2 points, a point a and another x. According to what we have just said, the slope of the segment connecting these 2 points is given by this formula. Now let's stretch or bring point x closer to point a. We see that the line approaches the true slope at point a. Bringing one point closer to another is what we call the limit. We denote it lim of x arrow a, for limit of x tending towards a. Just add the limit to our formula to get the derivative, or the slope at point a. Take for example the function f of x equals x squared and apply the formula. F of x is our function and f of a our function replacing x by a. We know that x squared minus a squared is the same as x minus a multiplied by x plus a. The 2x minus a simplifies and it remains. Finally, let's stretch or replace x with a. So the derivative or slope of x squared is 2x. If we replace x with a number, we have the slope in that number. For example, in x equals 3 we have a slope of 6. In x equals 1, a slope of 2. And in x equals 0 a 0 slope. By applying this formula to any polynomial, we can show that its derivative is n times x exponent n minus 1. There are many other formulas being possible to demonstrate thanks to our definition of which here are the most useful.
You didn't have to cut me off.